Section deals with differentiability. We just talked about the concept of differentiability with the two-sided derivatives. That function, the one we had in the last, this function, easier than redrawing it, going back here. This function that you drew here and looked at, this is not differentiable at 0. You can't find the derivative at 0. There is no slope at 0 because it goes like that, and then it has this sharp, there's this sharp corner there. If you say, what's the slope at that point? I kind of over-exaggerated this, but if you say, what's the slope at this point right here? There is no slope. Anywhere up here, the slope is 2. Anywhere here, it's whatever 2x is, 2 times the x value. But right at that point, who knows what it is? It isn't anything, because on one side, that's true. On one side, that's true. So it's not differentiable there. Okay? So this is how the derivative might fail to exist. I don't know why they talk about failing to exist rather than saying it's undefined, but they say that the limit doesn't exist and the derivative doesn't exist. Fail to exist. One is what we just looked at, which is a corner. Here's another function that has a corner to it. Okay? A function that has a corner to it. You know what absolute value? Can you put a little sketch of absolute value for yourself there? And think about what the derivative is on either side. The first graph of absolute value of x, right? Just looks like that v. Obviously from one side the derivative is positive 1. The slope's positive 1. If you start from the other side though, it's negative 1. Okay? The left-hand derivative is negative 1, right-hand derivative is positive 1. If you ask what is the slope at that point, at 0, it doesn't have a slope. The derivative is undefined there. Okay? If you want the next thing, if you graph, I think the next one was this cusp, right? It's the same thing here, although the derivative's changing as you approach the middle. If you put one point right there at 0 and then you start to approach, the right-hand derivative is what value here? Yeah, it's positive infinity. If you make that closer and closer, it's going to become positive infinity from this side. Whereas if you come from the other side, what is it? Negative infinity, right? The slope from the other side is different. So it's the derivative is undefined there, even though it seems like, you know, like you think, well, they're both going towards a vertical, but they're going towards opposite directions, right? And the next one was vertical tangent, I think. Vertical tangent, if you put 1 there, even though it looks like from one side it's approaching positive infinity, and from the other side it's approaching positive infinity, the slope of our vertical line is undefined. Okay? Slope of a vertical line is undefined. So even if something has a vertical tangent, its slope is undefined. And then the last one was this jump discontinuity. This one's going to have to be from either side here. Oops. Let's get rid of that one for a second and get this one in here. I think I have it backwards actually, but that's okay. From the right side, if you have you look at the line from the right side. If you put that there, the secant line from the right side of this function. Well, the way the function is the function is just this thing with a jump in it like that. So from the right-hand side, the slope is just 1, right? Slope is 1. Whereas if you approach from the left-hand side, the slope is approaching, what is it approaching? Positive infinity, right? So the derivatives at this point right here, at 0, is undefined because the slopes from either side don't match. Okay? The right and left-hand derivatives have to match. If you have a picture of that, if you've drawn a picture of each of those, it doesn't have to be a very detailed picture. If you got the wrong graph when you did this, you need to put the 2/3 in brackets when you use exponents on there. All right? So basically, I just showed you, I'm not going to draw the pictures here, but you can draw the pictures for yourself. This question, I don't even know why I asked you. It's a grade 12, remembering how to do grade 12 questions is basically what this is. This is like absolute value, except it's translated one way and another way. If you have the graph of absolute value, and you know what that looks like, if you have the graph of absolute value of x looks like that, and you want to move it, the derivative's undefined at 0. So if you move that 2 to the right and 3 up, where is the place that's going to be not differentiable? 2, right? Not differentiable at 2. You can use transformations if you know something about transformations to think about where they're not where it's not differentiable. Okay. This last thing that this is probably all we're going to have time for before doing some other stuff is, well, it depends how long it takes you to set this up on your calculator. I want you to look at these two different functions and then zoom in on the point that looks like it's not differentiable. So look at it under, first of all, look at it under zoom decimal on that calculator or equivalent calculator, the equivalent feature. Look at both of those and then zoom in on each one to see whether it's differentiable or not at that point. And then draw kind of a graph of each one far away and then a zoomed in part. Keep zooming in. So draw the graph, but then zoom in on the part that, well, I don't know where it's going to be, but the part where it looks like it's not differentiable, zoom in on that part a whole bunch of times to see what happens. And we can come back to that in a few minutes. Okay, if you only want one of them, that's one way to do it. I mean, other than entering it and erasing it and entering it again, if you unhighlight that. And then I think it's best if you go to this to see what it is. So that's the first one, absolute value. And then if you change it back to, I'm going to change the window slightly so that the vertex of the thing is in the center. So I'm going to go like this, 2, and then 4.1. Okay, so it's got that in the center of the screen. If you change it to the other one, you notice it looks almost the same, right? So that's highlighted. That's not highlighted. And then you graph it, except it graphs a lot more slowly. It takes a lot longer for it to do the calculations for that one. They both look the same. If you zoom in on this one, you notice it's actually a little bit curved down here. Hopefully you noticed that. If you do zoom in will shrink it down to, depending on whatever factors you have stored here. So if I zoom in on that, it does this. If you want to control how fast it zooms in, if you push zoom and go over to memory, and then you go down to set factors, that's where it tells it how much to zoom in. Mine is set at 4 here. I think that's the default. You could make it 10. It would go 10 times zoomed in every time you did it. You can make it 2. I don't know, whatever you want. If you zoom in again, I think you can just hit enter again once you've done it. I went off that screen, so I can't anymore. But if I go zoom in, and I've hit the center, it zooms in on that. I think if I hit enter again right away, it just keeps zooming in on that point to save you some time. That one's actually curved on the bottom. Even though it looks sharp from far away, when it's zoomed out, the more you zoom in, the flatter it looks. In fact, if you go in enough here, it just looks like a horizontal line, right? This is the same as the reason why people think the Earth is flat, right? Because close up it looks flat, far away it looks round, right? If you're on that, that basketball is obviously round from this distance, but if you're a little tiny bug on there, it's going to look more flat, right? The closer, the closer the scale is, the bigger the thing is relative to you, the more it's going to look flat. This thing is actually rounded on the bottom. So what is that? That's probably a lot of work just to see that this one is not differentiable. This one is differentiable at 0. This one looks like this, but if you look close up here, that one's sharp. If you keep zooming in on that, it's always that point down on the bottom. Whereas this one from far away looks like that, but if you zoomed in on this, it looks like that on the bottom, sort of. That doesn't look anything like that. It's sort of still straight, but right on the bottom it's like that. Is differentiable at 0. Make sense? We're going to draw the line there because I want to give you this quiz on the last little bit of the previous section. And then we can do this next time, next day. A good place to stop.